Okay, I'm recording follow-up to my last video because I found out what's the issue, because in my preparation for it I assumed that generally I will be able to create this entity extractor that's kinda manually done, but also use some of those parts like post tagger or entity detector from already pre-trained ones, for example, or already defined ones in case of rule-based ones. However, what I found out is that essentially if I want to do it manually, I have to more or less do it manually whole way. And doing manual entity detector would be a bit difficult. And I intend to do this. I intend to do this later on, but for now, we are going to do the following thing. I'm going to import SpaCy, and for this video, I'm going to quickly change my code in such a way that I will use SpaCy to get results quickly. I mean, we will have NER, but we'll have basically the NER that the whole NLP stack will look a bit different. The whole NLP stack will look as follows. So we don't have this. We don't have this. What we are going to have is we are going to have a single function called, let's call it NLP stack. It's a whole stack in one. And we will have text as the input. Right now, I won't be annotating what we'll be returning because I think I would like to return something interesting, at least if we cannot do this. Okay, so essentially what we are going to have is we are going to have document, and what we are going to do is we are going to, well, first we are going to create natural language processing tool from SpaCy. Load en core web. So sorry, in core web small. This essentially means this is English core database trained on web resources, and this is a small model because they are on the small, I think on small data set. It's trained on small data set and it's small model. Or no, I think web defines dataset and this defines model. Okay, so now let's get our documents and how completely and how much we need to write to get our document. NLP text, and here we have the whole document. And it essentially done everything. We can simply, for example, check for relations in here, so for entities in here, right? So let's have, let's make entities. Entities. Okay, maybe let's create a class for entity at least. So we at least will do something. So data class entity. So we will be doing this with more, and entity will have name, which I think is string, and label, I think label is also string, right? And now we are going to go entities equal entity label for in doc ends, right? And now no doc but document. Okay, and now let's go for entity in entities print entity. Okay, so now let's run our NLP stack on text. UV run source tutorials 0 to NER. By the way, I call this tutorials not because I'm making a tutorial, so I'm basically doing this as a sort of a tutorial for myself. So like I have like an example that I have my notes on, and then I'm trying to do it myself. And I decided to record it because maybe this will be helpful. Okay, so let's go to where I save this data. Alice, okay, and it's running. Okay, so we have entities. Alice recognized as. Okay, we already can see that this is not the best thing, right? Because it says that Alice is sometimes person, sometimes organization, and rabbit is low. Okay, this is okay. For a moment, let's have. Maybe we'll have a better better model for that. SpaCy English models. We are going to use different model: language type, gender, size. Okay. NCore web. This is the web one. Web. Only web. Accuracy evaluation. English. Only web. Let's go with medium, maybe. Let's go with medium. Or no, let's keep with that one. We don't have to be perfect. Okay, but as we can already see, we have repetitions. So let's go and let's have entities. Let's call this entity list, and entities will be set. So it's a set with from entity list, right? Okay, and now we should not have repetition, right? It's unhashable. Maybe it should be enough if I have a if I have something like that, right? This is essentially equality. Will it require me to be hashable, or is it enough if I am able to say? Because I think this should be enough, right? Because in the set we're just checking if they are equal. If is instance other entity, if not, of course, if not this instance, then return false, of course. Is instance is undefined. Instance is okay, so it's like that. Okay, and in another case, return self name equals other name and self label equals other label. Okay, let's now try. But you don't have to hash it. I overwrote. Okay, so let me. Why I do not understand why he needs. I will hash it, right? I will now try to remind myself how to hash in Python. Okay, Python make object hashable. Okay. Oh, and it's also a problem with set. Okay, so I don't really like this. I don't like how this set behaves, that it requires me to hash it. I'm kinda okay, I'm doing it manually because I don't like it. This is not how it should be done. Entities. This is list right now, so for entity in entity list, if entity not in entities append entity. Okay, and now it should be okay, right? Okay, so we have Alice, which is person, Alice, which is organization, and Alice and rabbit, which is law. Okay, so now once we have all the entities, let's print all documents in all verbs. For verb in doc, or let's call it word in doc, if word.pos is not equal to verb, right? Because this has to be verb, right? Continue in document. But the problem is this will kind of do what we want, but this is all black box. I want to do it not as a black box, but probably not for English. Okay, so let's have print word, and let's see how many verbs we have here. A lot of them. So now if this is a verb, we need to have subject and object, right? So we are going to have, and this is I looked at an example. This looks like subjects, because verb have subjects and objects, right? Subject acts on an object. So subjects, there can be multiple of them, and it goes like that. T for T in verb dot, word dot children. If T dot dep, so dependency of these children, is in, and here we have a set, tuple of, okay, I would prefer to do it like that. I will define this as subject dependencies equal, and here we'll have tuple with following n sub j and then n sub j pass. I need to, okay, let's go and let's try SpaCy. One moment. Before that, let's actually do something useful with that tutorial. So let's have, this should be word, right? This is object called word. Print type of word. Just type. Okay. I want to be sure. This is SpaCy token. It's called token. Okay. So let's go and let's say SpaCy token and documentation of len, set extension, get extension, has extension, remove check flag, similarity, envor, set more, has more, is ancestor, children, okay, and a child token such that child has self, and then the child is also a token, right? Yes, the child is also a token. So fields entity type, if this is named entity, and here is as an integer and here is a string. Okay, so this is essentially in such a way that you can use it as encoding, and in this case those are representative strings. Okay, so what we want to do is we want to check its dependency, right? So ABCD, it should be before dep, right? It's dependency underscore. Syntactic dependency relation. Okay, so in this case, and of course there is no convenient way to check documentation of syntactic dependency relations. So let's go SpaCy. I think this uses some standard, right? Standard names of this, right? Dependency parser, linguistic features, text, lemma, tag, dependency. Okay, so those will be standardized. So I need to have cheat sheet for those for later on. Okay, so now those are subject dependencies, and then let's have object dependencies, which will be in this case the obj and then object and attr, because it can also be attribute. Okay, so subject, okay, in subject dependencies. Okay, right, and then objects, if this is in object dependencies. Okay, so now instead of printing word, what we are going to do is we are going to print f string. First will be like this, sorry, like that, and then join, and it will join subjects. Then we'll have, sorry, and then we'll have word, then space, and then join objects. What's wrong with here? Subjects, objects. What's happened? Okay, sorry, I'm a bit silent, but okay. Okay, so now let's see. Okay, so now we can see that here we have Alice thinks out eat, rabbit run, there is no object. She is considering, we don't know what. Alice beginning, we don't know what. Rabbit took, watch. So we here we have, I think, okay. So what we will have now, and those are also tokens, right? Okay, so here we have tokens. So what we are going to do now is we need to get relations from it. So we are going to have, okay, so if you want this relation, we want to have subject, object, okay. So instead of printing it like that, let's create a class called relation class, data class. Okay. Relation. And then we are going to have maybe object. No, it's object, it's like, so target, right now str, and then we'll have not target but actor. Let's call it like that, and for now let's have it as a strings. I'm coming up with a more interesting project actually, and probably this one will be next one, because this is a bit of a something I'm going on the fly with. Okay, so let's have do we need something? No, this will be enough. And then let's go forward, and okay, and here let's have relations. Okay, and then instead of having this, the actor, target, and type, not action, actor, target, and action. Okay, if subjects and objects, so those cannot be empty if none of those are empty. For subject object in zip, I think it doesn't work like that. I want all possible combinations, I guess. Or maybe for now, let's go if subjects and objects. This is one. If sub length subject is equal to 1, because our method won't work well with multiple subjects or objects. So we cannot, with our method, we can only extract a relation if there is one subject and one object, okay? Or no, objects can be multiple. Because like you can take something and something and something, but you can, this can be only one. Okay, okay, let's keep it like that. This is not perfect, but let's think about more about this in the next version. Now, for this version, let's just have it working, okay? So let's go and let's have entities append. Am I recording at all? Yes, I'm recording at all. Entity, no, not entity, not entities, relations append. And here we are going to have relation where actor is subject, target is object, and action is the verb. So word dot token. Let's go back to token. Token. Like the basic stuff. Token. Vocab. Set. Similarity. Set. Morph. Children rights. Lex. Underlying lexem. Verbat in text context. So just text. Okay. Why is the, oh right, it has to be string because those are all tokens. Text. Okay, and now we are going to go and for relation in relations print relation. Okay, let's try it. Okay. Actor target pictures. It had pictures. Alice think it. She thought it. Rabbit took watch. She seen rabbit. It pop hole. Okay, so here we have those named entities. Then we have basically here we also have actors like it, she, it, right? We can guess from it that it is a rabbit, right? Because Alice, but not in here. Alice think it. Oh no, I think it. Alice is thinking about a rabbit. That the rabbits. Okay, for a moment. Cat data. Alice. Think. Where is the thing here? Features conversation. There is nothing very. Nor did Alice think it so very much out of the way to hear the rabbits say. Though this, it is not the rabbit. Okay, so we have something very basic here, right? And now maybe we can do something funny with it. I will think about something more interesting, but I'm not sure, do I really want to play with this more and do something funny, or do I want to do a more manual extraction? I think I will do more manual extraction, but now this is basically follow-up for the previous tutorial, and I mean tutorial video about making something, and I think I will stop at this moment, so we have half an hour for the last one and half an hour for this one, and I think I will later on try to stream some programming on Twitch, but maybe.